channel, please check the subscription button and subscribe for more wonderful videos. Okay, so now we're going to look at how to find the differential equation of a given function. So when a function is given out to us and we are asked to provide the differential equation, how can you go about this? So this tutorial contains only two ways, that is in two ways in which if the function is expressed you can go about. So first, actually my previous video we talked about order is the number of times the function has been differentiated, but in this situation an order is the number of arbitrary constants in the function. Now you understand what I'm saying, because when we talk about arbitrary constants in the function, that will help you to know the number of times in which the function can be differentiated, or in which when the function is given to us to provide a differential equation, in which you can follow to what? Differentiate. So let's take, so we are starting with this one. If a question is in this form, that is y is equal to a sine bracket open bx plus c, we are going to look at how you can solve it, right? It can be sine, tan, any. So we're going to look at how we can solve it. So with this, now I asked about the order. So with this, for us to calculate for the order, you must look at the constant, that's the arbitrary constant. So with this, we have a here is a constant and c is a constant. So with this, you know that your answer or the solution to the differential equation must have two derivatives. It means that we have two derivatives because the order here is for this function is 2. So normally when a function is given to us, you must always find the order, because if you find the order, it means that you're going to differentiate the function equals to the order. So if the order is 2, it means you're going to differentiate the function 2 times and do your what? Mathematical addition or subtraction to find your y1 and everything. So let's get continued. So now we have a question like this, which is similar to this. So y is equal to a sine omega t plus b. Now one may ask, how many constants do we have here? We have how many constants? So we have a is a constant here and b also is a constant, but with omega t, we are differentiating respect to t. So omega t is a value but not a constant, so it cannot be part. So it means that this equation can be what? Differentiated twice. So first you find the first derivative of the equation, which is a omega cos bracket open omega t plus b. Yes, so you differentiate this first because it is having two constants. You need to do it 2 times. So you find the second derivative, which will give you a omega squared sine bracket open omega t plus b. With the differentiating, this is very simple because we are differentiating with respect to t. So when you do that, you're going to get this. Now after getting this, how do we arrive at our answer? So we have done the first and the second. This is because of the constant, the number of constants, which is given as the number of order. So after doing this, you must make sure that you do everything possible to eliminate some of this one, because you don't want to get a sine or the cos in your differential equation. So you must do everything possible to what? Eliminate the sine and the cos. So what can you do? So when you check for equation 1, so you check in with the equation. So with equation, we have, let's assume this is equation 1. This is equation 1 and this is equation 2 and this is equation 3. So we have 3 equations here. So you check through which equation are you going to use or what are you going to do. So for this, when you see that when you divide equation 1 over equation 3, you know that you can do some cancellation and it will make the sign. So when you do that very well, it depends on what you do. Some can use simultaneous equation, anyhow you wish to do it, but the main idea is to find the number of order. If you know the number of arbitrary constant, that will tell you how many times that you would differentiate the constant to eliminate the one. So with this, when you do this correctly, it means that a will cancel a, the sine omega t plus b will cancel sine omega t. So at the end, you get the expression y is equal to y double bar is equal to 1 over negative omega squared. Yeah, sure. Yeah, that reminds me, because when you differentiate cos, you must get negative. So this side is negative. Yeah. So that's why we have this negative here. So this side will be negative, because when you differentiate sine with respect to when you differentiate cos with respect to t, you are going to get negative sine. Yes, that is differentiating. So differentiating here. So with this, you're going to get y, and you do cross multiplication. When you do cross multiplication, you're going to get y double bar is equal to this, and when you do that correctly, you're going to get this. So this is the differential equation to the function. So we know that we can verify from our differential equation that this is second order. This because the order is 2, as you can see, because we have two arbitrary constants. Yes, from the function given to us. So it means that our answer is correct. Yeah, that is it. So you must always know the number of arbitrary constants that will determine how many times the function will be what differentiated before you eliminate to get your differential equation. So this is the first way if it is expressed. And also, let's go to the exponential. So if we have a question which is expressed in an exponential form, that is y is equal to ae k1x plus bec 2x. How are you going to do it if it's in this form? Note, if it's only in this form, what you do now is we have a formula that you must always note. Yes, you must note that. So since you find the order, or to find the number of arbitrary constants, we have the first order, which is the 1 and 2. So the arbitrary constant is 2. Yes, so the arbitrary constant is 2. Therefore, you are going to differentiate this 2 times. So when you differentiate this 2 times, it means that the number of you're going to differentiate this 2 times. So when you check this equation, which is equal to y double bar minus. So this is because we have 2 arbitrary constants from here. So we are going to use this formula. And with this, the k1 represents the exponent here, and the k2 will represent the exponent with the what? B. So let's take a question so that we'll try on that. Okay, so when you take this question, that is y is equal to e exponent 3x plus this. So this, let's compare this to this, and let's use this formula. So we know that now with our k1 becomes 3 and our k2 becomes 2. So when you do that correctly, you're going to get y, that's the second derivative, minus bracket open 3 plus 3 plus 2 first derivative, because with this formula it is similar to this. So you are just putting in the value. That's why it is good for you to know this formula in your head. So when you do that, you're going to multiply for the same thing, and when you do that correctly, you're going to get this as your answer, as you've seen here. So you're going to get this as your answer because we use just the formula. So what you need to do, just put the formula in your head. One may ask, what if the arbitrary constant is 3 for this exponential? Okay, if the arbitrary constant is 3, like this, as you can see here, the formula you use is this one. Very long, lengthy. It's very simple to keep in your head so that you know that this become your k1, k2, k3, and just put in the values to find the differential equation of that function. Yes, so that's how we do it. Very simple. Yes, so please, once again, your subscription will be a very great count to my YouTube channel. So please, if this is your first time or second time, third time, and you've not subscribed, please make sure you subscribe. Hit the subscription button and subscribe for more videos. Thank you. Hello guys, welcome to Prof1 YT, and I really appreciate your subscription. Thank you very much. So today's video is on calculus, that is continuation with first order differential equation. So we're going to take some examples and solve using the general and the particular solution. Yeah, so today's video will not be done by Prof1. I have a special guest here who's going to do this video for me, and She's very, I don't know how to mention her, intellectual, very, I don't know, you hear from her. So, hello, what's your name?
I'm Francis.
Francis, very nice name. So her name is Francis, and I know that you've not heard it before, as I've not heard it before. So Francis, take over.
Thank you so much, Prof, for this opportunity. Hello, guys. So today we are going to be doing solved examples under first order differential equations. The first thing that I want you to know is that there are a lot of methods that you can use when you are solving first order differential equation. But it depends, okay? The solution that you can use depends on how the arrangement of the questions are. So let's not waste time. Let's get right in the homogeneous method. So that one, you have to identify if the question you are given is homogeneous.
And how do you identify if a question is homogeneous?
That is when the power, okay, on both sides of the equation are the same.
So that means they have the same degree, right?
Yes, please.
Thank you very much. Oh, that's very nice. That's very nice. Okay, so the question is here, so
Yes.
you can continue.
But before we continue, there are a lot of ways, okay, of identifying if an equation is homogeneous. So that one, we'll talk about it in another video, so expect that.
Yes.
So one thing about the homogeneous method is that we will do something, okay, we will substitute a certain equation into the question so that it can be easy for us to separate.
Very nice.
So in a way, the homogeneous is kind of a higher level than the separation, because when you are giving the homogeneous, you have to try and substitute so that you can then separate. So let's continue. So what you are supposed to substitute. What you're supposed to substitute, we'll talk about it. But before that, let's change the y prime, okay, to dy ds so that we wouldn't get confused, right? Yes. So now let's talk about what we are going to substitute. You have to substitute what y equal to xv. Y equal to xv. And this expression, you have to also substitute other stuff into the equation, okay? So the simplest way of remembering all the substitutions is that the first one, remember y equal to xv. After that, differentiate y equals to xv. So you get dy equal to x dv plus v ds. So we have this because there is a multiplication of s and v. So you use, according to differentiation, right, the principle of multiplication when the product rule, yes, the product rule. So we are trying to make dy dx the subject.
So with this, we are trying to substitute in with the expression. That is, if you check this equation, it's the same equation here. As you know that x prime, xy prime is the same as x dy dx. And as we've substituted with y, which is xv here, so it's the same substitution here, and x. So this is the same equation for this, just that we've done some substitution.
Sure.
Let's continue. We can continue.
So as I said earlier, you have to substitute what we've talked about, that is the y equal to xv and its derivative, into the question that you are given. So after doing all that, we then arrived at s dy equal to dx into bracket vs plus x.
What we did here is that we try to cross multiply so that we can make, you are trying to move x to one side and v to one side.
Sure. This is, so after substituting the things that you have to substitute, then you come to the method of what? Separation. So now we have reduced the equation to what? Separation variable. So we have to separate them. So we are separating the s from the y.
Yeah, very nice. But now we know that the dy has not been substituted. So now we are going to substitute in with the dy, which is equal to s dv plus v dx.
Sure.
Yeah.
So at this stage, we are not having s and y's, but rather we are having s and v's.
X and v's, yeah.
So we have to separate the s from the v's. Yeah. So let's do the separation well.
So when you do that, you are going to multiply through by x so that we eliminate this x from there, right?
Sure.
So when you do that correctly, this will cancel this, right? and this will be over. So when you do all the equation, and this s also will take care of what this
The
x.
x.
So what you get here is this one.
Sure.
So now we try to make let's do something here. We try to expand it, and when you
Sure.
expand it, you're going to get s du s
The
dv plus v dx, which is
Sure.
equal to v dx plus dx. And as you can see, when you send this one here, this can take care of what
Yes.
this,
Sure.
right? So at the end, you're going to get this.
Sure.
But with the x must go with the dx.
Yes.
So we try to divide through by 1 over x,
Yes.
and when you do that correctly, you're going to get what dv is equal to
the s on s.
and that can be expressed as you find the integral. Yes, and when you find the integral of that, you know that when you find the integral, you're going to get v ln c plus v ln x plus c.
Sure.
That will give you the answer.
Sure.
Yeah. So I'm very happy that you did this video. How do you put that? Oh, yeah. Can you say something to our subscribers so they subscribe more and share our video?
Sure. You people are very lucky and blessed to have Prof solving wonderful questions with you people. So I'll advise that you continue watching. And then those who have already subscribed, we thank you for your subscription.
Yeah,
those who are watching for the first time, we want you to subscribe because we have wonderful content for you, very educative.
Thank you very much. You're welcome.